Dependency injection. So after all the fire that burned during these weeks on Twitter, I decided to do another video about dependency injection and all the concepts that lead you to that point. I don't want to get into those conversations again, what is better, what is not, Kotlin versus Dagger, all that. You can see all the Twitter conversations that are being done these days, and I already gave my position in some of these Twitter places in the YouTube community. So let's move to something that I believe it's more important than all this ramble and all this noise, which is the concepts that you need to understand what dependency injection is, and that will help you understand the difference between a service locator or a dependency injector. And apart from that, what I mentioned, all the concepts that you need to go from one place to the other. So welcome again to another video, and I hope that this helps you to understand all the difference between all these very similar concepts. But first, to understand what dependency injection is, the first concept of all of this is a dependency. So what is a dependency? A dependency is simply an object that your object has to rely on to finish its work or its task. In oriented object programming, it's clear that an object by itself cannot do everything, all the work that an app needs to complete its tasks, unless you are putting everything inside an object, which is obviously not a very wise solution. So in your app, you will probably have some objects that need to interact with other objects to do a task, and that's a dependency. This object is depending on the other one to do everything it needs. So how can we define those dependencies? There are a lot of ways, but imagine in this case the request new location. This is again the clean architecture sample that I've used for other videos. Here we have a use case, request new location, that requires a repository to interact. So what can we do? We can create here the dependency, the new object, and then use it when we have to use it. The same happens with the locations repository. This needs a persistent source and a location source. And we are doing here the instantiation of the dependencies that we need. So when we have to use it, we just have created the object here, and we can use it in the next line or wherever we need it inside that class. So the dependencies are being defined by the object that needs them. This is a bit dangerous because if any of these dependencies need to change, the code in this class needs to change too. And this can affect other objects inside the list of dependencies. So it's really interesting that when we are using dependencies, we don't create them inside the class. And this leads to another couple of very important concepts that it's also important to differentiate between them, because they are usually used in the same way, even if they are not exactly the same. The first one is the dependency inversion principle, which states that our classes should not depend on concrete definitions of other classes, but rely on abstractions. So if something changes, our class doesn't need to change. This, we are doing it already. If you see here, our dependencies are in fact interfaces. We can go here and see them. This is just an interface that defines what a location persistent source should do. But in the end, we are using a concretion. So here we are already doing the dependency inversion, because we no longer rely on specific implementations of these persistent sources, but we are interacting with an interface. The second concept that you need to understand is the inversion of control, which is slightly different to what we said before. The inversion of control states that instead of being us who declare or identify the dependencies that we are going to work with, it's another entity or framework, the one that is providing the dependencies for us. And to do that, instead of being us, the ones that are instantiating the classes, the dependencies, we usually rely on them being provided by using the constructor. So here, instead of doing this, instead of creating here the dependencies, what we would do is that we will have here a locations data source that we can convert into a private property, and the same for the device location data source. That way, if we need to change in our case, the persistent source or the location source, we don't have to do it inside this class, because this class is already completely abstracted from that. It will be another entity or another framework, the one in charge of providing these dependencies. And here it comes into game the idea of dependency provisioning. Now that we are not creating our own dependencies, something has to provide them for us. So we'll need some kind of entity that starts doing this work. And this is a very important work once we start working with inversion of control. And that can be done in several different ways. The simplest one would be to use one of the features of Kotlin, that is the default values for the arguments. So here we could provide the in-memory location persistent source, and here the fake location source. As I mentioned, this is helpful for very simple projects, but this is really limited because we will be able to modify these dependencies only in unit testing. For instance, if we are only doing very simple unit testing, we can get this class and provide different dependencies that can be mocks or fakes that then we can use in our test without having to add much more complexity to our code. But as you can imagine, this is, as I mentioned, very limited. If we want to do, for instance, an integration test where several layers are being interconnected, we cannot provide dependencies for the middle steps, for instance. So use this solution with care. We cannot solve everything just with this approach. There are a couple of other very popular approaches. One of them is a service locator, and then the other is the dependency injector. So what is a service locator? A service locator, as its name suggests, is just an object that provides the services for us instead of having us to do everything by hand. We'll see an example later on how everything can be done by hand. What you can do is to use an object, an entity that provides the dependencies for us. It's very important to understand that service locator doesn't need to be used with inversion of control. But let me first write a very simple implementation of a service locator, and then I'll explain you why you don't need it. So for instance, here in the root, we could create an object that is called SL to simplify, and then we would probably have a couple of methods. One that would be called get, that given a dependency of type T, it returns an object of type T. I'm not doing the implementation, I just want to write the structure of this possible class. Let me do it like this. And then another function that could be called put, for instance, that again is generic, and given an object of type T, this would add the dependency to our set of dependencies. So this could have some kind of data structure that puts the object inside the structure, and then with the get recovers them from this data structure. So it's very simple, the concept. And why I said that service locator doesn't need to be related to inversion of control. This is because, let me get back to our previous implementation here. In general, when you use a service locator, what you do is to tie all your classes to this service locator. So here you would do something like service locator.get and service locator.get. So you use the service locator to recover these dependencies. I mentioned that they don't need to be related, inversion of control and service locator, but if you want to do it a little cleaner and simplify testing and also even simplify migrations, if you once decide to move from a service locator to a dependency injector, it can be interesting still to do what we had before and move the dependencies to the constructor. And then you would do service locator.get in every of the dependencies that we are receiving through the constructor. So as you can see, the service locator idea is very simple. Instead of providing those dependencies manually, you can do it by using a service locator. The pros of this is that a service locator is very simple to understand. The concept is really simple. It's just a set of objects that you have inside another object, and the service locator helps you recover those objects. In general, the concept of service locator is used when you have a very well-defined set of services in your app that are usually singletons, and you want to get them from different parts of your app. If this gets more complex, the service locator becomes a little difficult to use. The first reason is because the service locator is usually only providing singletons, even though, as we saw with Coin in the previous video, if the service locator is powerful enough, you can also get an instance every time you need one instead of just singletons. And the second reason is because the service locator does everything in runtime. So if there are compilation time problems, you are not going to get them. For instance, if we have not added a location persistent source into our service locator, this is not going to crash until this code is executed. So the pro is that it's simpler, it's very easy to understand, and people can start using it from the very beginning without having to understand very complex concepts. But the con is that it's less powerful, is less secure, is less safe, and also that it's probably less performant because it has to do everything in runtime. What I'm doing here now is getting back to the original code that I have in the repository regarding clean architecture and reverting all this because I want to show you something. Once you have done the inversion of control everywhere, the problem that you have if you are not using a service locator as we saw before, that we were providing the dependencies right into the class, is that when you want to create all those dependencies, you get a code like this. For instance, this main presenter requires the view, this one needs to be passed anyway, and a couple of use cases, get locations and request new location. These two use cases require a repository, and the repository needs also to be created here, location repository with a persistent and a device location sources. If you do this inside the activity, you are polluting your activity with all this code that would require to be done by another class. You could, for instance, extract this to another place, or doing those middle solutions that can even be enough for very small apps. But when this starts becoming more complex, everything will become quite messy. So the next step you can do is to use a service locator as we saw before, or to use a dependency injector. And what's the difference between a service locator and a dependency injector? If you saw, when we use a dependency injector, we always have to recover the dependencies ourselves. We need some kind of method, as the get that I implemented before, that provides those dependencies for us. But in the case of a dependency injector, all the dependency provisioning is done kind of automatically. And how we get that? The only thing we need to do is to mark the constructors with an annotation that is usually called inject. You will see here that is not compiling because I don't have any of the required libraries. And with that, the injector is able to look for the dependencies and provide them in compile time. This is more interesting because thanks to doing it in compile time, the libraries can add some extra features like checking that the dependencies are really in the injector and crash if it's not the case. But this can be provided by the libraries if they want to implement it, but it's not a requirement. The only requirement is that just by annotating the constructors, you can get the dependencies for free without having to explicitly call to the injector or the service locator, as in the case before. The dependency injection is usually very low performant because traditionally it was done by using reflection. And this is a problem, obviously, and more in the case of Android, where the reflection can penalize a lot in the performance of our apps. But Dagger took a different point of view, and instead of doing this by using reflection, it does it by generating code, so that the code is created by the time the app is run. And in that case, the dependencies are provided automatically without having to rely on reflection. This is great because of what I mentioned before, because we can know in compile time whether a dependency is available or not before even running the app, and also because as the code is generated by the time the app is run, we also have the best performance possible. So in theory, we have the best of all worlds by using Dagger, but the reality is that the configuration of Dagger is a little bit complicated, and the learning curve is quite more steep than using a service locator or a library like Coin. So that's why I mentioned in the previous video that sometimes it may make more sense to use Coin rather than not using anything in your projects. But if you ask me what is the most powerful library out there to do dependency injection on Android, obviously Dagger wins in several aspects. The reason why this configuration is not so straightforward is first because you need to provide all the information to Dagger so that it can create all this generated code to do the dependency injection. And second, because even if this inject that I mentioned here is so simple, it's true that you cannot use it everywhere. First, because sometimes the dependencies are not so straightforward. You may have an interface as a dependency in the constructor instead of having a concrete implementation because of what we mentioned at the very beginning, because of the dependency inversion principle, or you are interacting with a third-party library that obviously don't have those inject annotations in their constructors. So even if the configuration is simplified by using those inject, you will need to add some extra things. And also what I mentioned, because of all the information that you need to provide to Dagger so that it can create the generated code. And now I can guess that what you want is a specific example by using Dagger. But if you want to see this happening, you need to show me your love in this video by liking the video and also subscribing to my blog here below, so that I can understand that you are really interested in this topic and I can continue creating videos about it. Help me reach 100 likes in this video and I'll make it happen. So thanks again for being here and for letting me explain all the concepts that you need to understand before start doing dependency injection. And As I mentioned in a following video, I will explain how to use Dagger, all the main concepts that are included in this dependency injector, and how you can start using it in your own projects. Thanks, and see you in the next video. Bye!